and you're given how many grams of carbon dioxide and water are produced. And hopefully by now I've stressed that you can't do anything with grams. You can't compare grams of one product or reactant to another. You have to convert them into moles. So the first step, if you did not write out at least some sort of equation, your first step should have been to convert each of these into moles. And 2.641 grams of carbon dioxide is equivalent to 0.06 moles of CO2. And then 1.442 grams of water is equivalent to 0.08 moles of water. Now that now you have to keep in mind that for every 1 mole of water that is produced, there are 2 moles of hydrogen involved. 2 moles of hydrogen are produced for every 1 mole of water. So you have to double this number of moles of water to get the number of moles of hydrogen. So when this quantity of propane combusts, it actually produces 0.16 moles of hydrogen. So I'm comparing 0.16 moles of hydrogen. I'm going to actually just bring that to this.
That's what you have to do.
2.66.
Because for every 1 mole of water, again, 2 moles of hydrogen are produced. So that gives us 0.16 moles of hydrogen. Now I can compare these two, and I'm going to divide by the smaller amount, the 0.06 moles of carbon. And that gives me a ratio of 2.66 moles of hydrogen per mole of carbon, which is clearly not a whole number. I have to have whole numbers. So 1 to 2.66 is not a whole number relationship, so I can't use that. So I'm going to double that. I'm going to double that ratio, which means multiplying both sides by 2, and that gives me 2 to 5.33. So I can't use that ratio either. If I triple the ratio, that gives me 3 to 8, and that is a whole number relationship. Therefore, the empirical formula for propane is C3H8. For every 3 carbons, there are 8 hydrogens in that formula.